Welcome. We are continuing in Chapter 7, exploring measures of variability. The focus of today's video will be testing for the difference in standard deviation. By the end of this video, students should be able to explain the difference between a true and observed standard deviation. You should be able to calculate the difference in standard deviations, and given simulation or simulated results, students can estimate the p-value and make appropriate conclusions. So this is where we're really going to take the material from standard deviations and apply it to some of the things that we've learned earlier this year. So testing for a difference in standard deviations, right? Just like I just said, we're going to look back at some of the ways that we've done this earlier in the year and use the standard deviations to apply it. Now, just like we never truly know an athlete's ability, right? We just have to estimate it based on performances, right? That standard chance or random chance is what comes in and has that effect. Same thing with standard deviation. Okay, so when we look at that idea, right, true standard deviation, right, would be their standard deviation after an infinite number of performances. But obviously, they don't have an infinite number of performances. So again, just like before, right, we have to use what we can observe. So we're going to use observed standard deviation, okay, as a standard deviation based on the performances. Okay, so obviously, right, this is just an estimate of what the true standard deviation would be. Okay, so keep in mind that the observed standard deviation will vary from the true standard deviation due to random chance, just like performances deviate from ability. Okay, so our focus today and what we're going to use for our example is golf. Okay, so for those of you who've never golfed before, we will do a little background. And for those of you who have golfed, hopefully you can quickly follow this. Okay, so we're going to talk about 7-iron. Okay, and the idea of this, or the premise of this, is going to be which 7-iron is more consistent. Now, hopefully it makes sense to everyone, right? That knowing the distance that you will hit a ball with a given club is a good thing, right? The more consistent it is, the more you understand and know about it, right? The better equipped you'll be to know which club to use when, right? So it's very, very important. Okay, that's part of what caddies are there for, is to help golfers, like, okay, this is the distance and this is the club. So it's a big statistical thing that's used here in golf. So if you know exactly how far you can hit it with that, it just makes a massive, massive statistical advantage. Okay, so let's look at an experiment to determine if a golfer is more consistent with a new 7-iron or with the existing one that they've been using. Now, for example, we're going to talk about Jimmy. Okay, he's going to be looking at buying a new 7-iron. Okay, hoping that it'll help make his shots more consistent. He's been struggling with it. Okay, so he decides to conduct an experiment. Now, luckily for Jimmy, he happens to have a twin brother who's the same exact size as him, so his clubs fit him perfect, that just happens to have the new 7-iron that Jimmy wants to buy. Right, so that means we can use his current 7-iron and his brother's 7-iron to see which of the two clubs makes the difference when he hits a 7-iron. Okay, so again, remember, we're looking for which one, right, has less variability in it. Not necessarily which one he can hit further, but which one is he more consistent with. Okay, so when we're looking at the explanatory variables and the response variables for this experiment, right, our explanatory variable will be the club, the new club or the current club. Okay, whereas the response variable will be the distance that each ball travels when it's hit. Okay, so what are some of the variables that we want to control? So if you start to think about it, hopefully you can come up with at least a couple in your head. If you're not a big time golfer, maybe, or you've never golfed before, maybe some of these things you wouldn't know. So a few things that we want to take a look at, right? You'd want to make sure he's wearing the same shoes when he swings each club, that he's hitting the same exact kind of golf ball, that he's wearing the same golf gloves if he's using them, he's hitting them from the same location, right, around the same time, right, to try and keep all the variables that we can consistent. Okay, so let's say he's going to hit 20 golf balls in total, right? So how can we randomize, right, this experiment? Well, what you can do, right, he's going to hit 20 golf balls, right? So if we randomize the order in which the clubs are used, right, then we can just take 20 note cards, right, C for his current on 10 of them, right, N for the new club on the other 10, shuffle them all up together, and then take them out one at a time. And for that shot, he's going to use that particular club. Now, is it possible for Jimmy to be blind in this experiment? So is it possible for Jimmy to swing these clubs and not know which club he's swinging? Not really, right? He's going to know what club he's using, okay? And it'd be pretty difficult to try and disguise them, especially if one is used a lot and one is a new club. Okay, so let's take a look at some results. Okay, so if we look at this, okay, his distance with his current 7-iron is up on the top of that chart, and the bottom is the distance with the new 7-iron. Okay, these same values are also plotted right here on this dot plot. And you can see, I mean, it looks to be, right? What does it appear to be? Well, it appears that the new club is more consistent, right? They're tighter grouped. They don't go as far to the left or to the right. So it appears to be much more consistent. Okay. So hopefully you guys all were able to pick that one out. So let's perform a hypothesis test using the difference in observed standard deviation, right? The current club minus the new club is the test statistic, just like we've been doing all along. Okay, so what would our hypothesis for these be? Well, remember, we have to have a null hypothesis and an alternative hypothesis, right? There's always two parts to a hypothesis test. Okay, and the null is always that nothing changes, right? So the null hypothesis would be that Jimmy's true standard deviations are the same with each club. And then the alternative is what we think is going to be true, right? And that's that Jimmy's true standard deviation is smaller with the new club than with the current club, because we said it appears as though those are grouped together better. So how do we do this? Well, the first thing we have to do is come up with our test statistic, right? So if we go through and we use the methods taught to us in the previous lesson, okay, so you can go back and watch that if you need to remember how to find the standard deviation, right? So the current club was 13.56 yards, and the standard deviation of the new 7-iron is 7.72 yards. So these numbers, again, right, make us at first glance to believe that we are right, but we need to prove that we're right. Okay, so what's the value of our test statistic? Well, we have to do that 13.56 minus that 7.72, which gives us 5.84 yards as our test statistic. Now, just as we've done in the past, we can use a simulator to run trials, okay, of this simulation. In fact, if you go back to where we did some of the previous ones on that same exact website, there is a simulator. So we're not going to worry about it right now. We're going to worry about when you get the results, can you interpret those results and understand and then make appropriate conclusions? So instead of taking the time to show you how to use the simulator right now, we're going to go right into giving you some simulated data. Okay, so here is the simulated data. So the simulated difference in standard deviation for the current versus the new with 100 trials. Okay, and we said, right, that it was 5.84 yards. Okay, so we are looking, right, when will it be more than that 5.84 yards, right? 5.84 yards. Okay, so our p-value is greater than only these 3 times. Right, we have 3 times that it's at 6, that's 6 and above. All the other times, right, it's under 5.5. So if that's 3 out of 100, that's only 3%. Okay, so if you remember back to what we talked about in the past, right, that magic cutoff value, right, that we always talk about is 5%. So if our p-value is only 3%, the conclusion that we can make then, right, is that it is convincing evidence to support the claim that Jimmy's true standard deviation is indeed smaller than the new club. So, right, we get to reject the null hypothesis, and then we get to accept the alternative hypothesis. Okay, so that conclusion, right, tells us that he'll be more consistent than if he uses the new club. It wasn't just by random chance. So hopefully you guys found this enlightening and helpful. Good luck on your assignments. And if you have any questions, as always, just let me know as soon as possible. Have a great night.